Okay, so here's an ellipse, and defined parametrically, we know x is equal to a cos t, and b is equal to y is equal to b sine t. And we want to find the locus of the midpoint of a, b. So any point on the curve, we want to find. So let me just, if I draw another tangent, okay, just to demonstrate that the midpoint doesn't necessarily have to be a tangent. Okay, it's just a point. So if we draw another tangent, let's say here, to the curve like that. Okay. Now you can see that, supposing now, okay, so at this some other point, yeah, let's call it P prime, this tangent cuts the curve at A prime and B prime, and the midpoint is the midpoint of this distance here. So about halfway, we'll have that coordinate. Does that make sense to you? Yeah? So this is now the midpoint of the tangent, the midpoint of A prime, B prime. Okay, so it's about here, about halfway through the line. So now we want the general equation for all points that satisfy this condition, which is an equation for the locus of the midpoint AB as P moves around the ellipse. Okay, so as T changes, what happens to all the midpoints? So can we get an equation for that? Well, it turns out we can. The first thing we need to do is work out the equation of the tangent. Okay, so what is the equation of the tangent to the curve? Well, like any straight line, we need the gradient of the tangent. Okay, so dy by dx is equal to, and it's parametric, so it's dy by dt divided by dx by dt. Okay, so dy by dt, so it's b cos t all over minus a sine t. Okay, that is the gradient. Is that right? And now the equation, therefore, at the point a cos t, b sine t at some general point P, what is the equation of the tangent to the curve? Well, it's y minus y1, so it's y minus b sine t is equal to the gradient okay, and we can multiply through by a sine t. So should we do that? Let's multiply through by a sine t. So it's going to be a y sine t minus a b sine t is equal to minus sine squared t, good, minus b x cos t plus ab cos squared t. And if I rearrange this, and I can see that if I take this term to the right hand side and factor out ab, I get just ab times 1, because sine squared plus cos squared equals to 1. So I'm left with the equation of the tangent is a y sine t plus bx cos t is equal to ab. That's the equation of the tangent. Good. Now, what is the coordinate of a? So let's go back to this. What is the coordinate of A, where the tangent cuts the x-axis. Sorry? When y is 0. Okay, so when this term is 0, then A has coordinate what? A over cos t. So it's A sec t. Is that right? And what is B equal to when x is 0? So what is the coordinate of the midpoint? So any point, not quite. So any point x, we want the locus of points that is the midpoint. So let's call it capital X. Okay, just like small x, but so as to not confuse, we're going to call it capital X. Capital X has to have the midpoint. Okay, so it's just A sec t all over 2. And capital Y is equal to B cosec t all over 2. Okay, so any x, y, that is the midpoint of where the tangent cuts the x-axis and y-axis, the point AB where the tangent to the ellipse cuts the x-axis and y-axis, will have coordinates x, y, satisfying this property. Yeah? Are we all clear up to here? Okay. This is now the parametric equation of the locus of points satisfying that condition. So now I want you to have a think about what would be the Cartesian equation. Okay, so we've got this. Now if we wanted the parametric equation, so we got the parametric, if we wanted the Cartesian equation, we can say that 2x over A is equal to sec t. And therefore, A over 2x is equal to cos t. Similarly, B over 2y is equal to sine t. And we can eliminate the t by saying that squaring and adding and that is the equation, the Cartesian equation. So if we go back to the question, find an equation not of the tangent, because we can work out the equation of the tangent easily, can't we? But for the locus of the midpoint, AB as P moves around the ellipse. So we're not looking for the equation of the tangent. That's very straightforward. We've got the equation of the tangent right here. This is the equation of the tangent as P moves around the ellipse. Is that right? Yeah, this is any point P. This is the equation of the tangent. But we want the equation of the midpoint of AB. So we have to find out in general what the midpoint is. This is the midpoint. Okay, and then from there we can eliminate and find the Cartesian equation.